girls are so funny.
Hey, I pick up your bill.
Oh, thanks.
How's it going, man?
Not too. $400?
Seriously?
For electricity. I can't afford this much. I can't afford summer school after this either.
It's probably because you're watching too much TV.
I don't watch too much TV.
Yeah, you watch Gossip Girl, man. And
No,
the hills. And vampires there, are you kidding me?
I can't help it. It's like a drug. But it can't possibly be the TV for all this. You know, it could be the fridge, computer, and my server.
Yeah. You need to figure it out. Because you're basically killing the environment.
If only there was a way to monitor my electricity at home. Energy and electricity conservation is being more and more of an issue. Electricity costs are always on the rise, and people are increasingly concerned about environmental impacts of renewable energy. Or according to the participants that we surveyed, cost saving is the primary driving force behind using less electricity, followed by environmental concerns. To help people with energy conservation, we tried to design an informative and intuitive interface for a home electricity monitoring device. The device would be able to show various statistics, such as the overall and projected usage, set usage quotas, and show the power consumption of individual appliances. The participants also feel that being able to compare appliances would be the most useful feature. Because this is also the most interactive part of our interface, we designed 2 prototypes for a usability experiment. One prototype is a checkbox-driven interface, where the user selects appliances, then chooses a function to perform. The other is a drag-and-drop interface, which allows users to click and drag appliances to destination locations to perform functions. We created 3 tasks: comparing appliances, adding and editing appliances, and deleting disconnected appliances. 10 students were recruited, all experienced computer users between the ages of 20 to 29 to participate in our experiment. We wanted to find out which interface produced less user errors, is faster to use, and which they preferred. The data was recorded on the time they took and the errors they made for each of these tasks. After analyzing these results, we were able to make some conclusions. Of our hypotheses, we can accept that 1. The user performs faster on the drag-and-drop interface than the checkbox interface, and 2. The user produces less errors on the drag-and-drop interface than the checkbox interface. Although 7 out of 10 participants report that they prefer the drag-and-drop interface, this did not produce a statistical significance. Thus, we must keep our null hypothesis that the participants have no preference for one over the other. Based on the results from the experiment, we suggested that a hybrid of the drag-and-drop and the checkbox interface would be suitable for a future design. This project is still far from completion, as we met with experimental and time limitations. It would be interesting to evaluate the prototype with our original targeted users, which are families and homeowners who live in houses rather than students who live in apartments.
Is that Gossip Girl?
No, I was just doing film research.
Oh, yeah.
But you know, that problem that I had with power monitoring, I solved with EMD 444. Check it out.